Hello friends, this is beam balance. This is beam balance. This is beam balance. We have different types of balance. We have the chemical balance, we have the beam balance, we have the spring balance. But today we'll be looking at how to read the values of the beam balance. How to read and record the values of the beam balance. What that is. You see that nonsense? So measure the beam balance. The objects must be placed on the left hand scale of the pan. This is the spin balance pan. This is the pan. It must be placed at the left hand side of the pan. And these are known masses. These are known masses. And this masses is 1000 gram. A known mass of 1000 gram. This one is a known mass or standard mass of 500 gram. The standard mass of 500 gram. This other one too is a standard mass or a known mass of 1000 gram. So all these masses can be measured using the beam balance. So in the beam balance, the next thing you need to know is the reading accuracy of the beam balance. The reading accuracy of the beam balance is 0.001 grams. That is the reading accuracy of the beam balance. The beam balance, the mass of an object is then obtained by adding standard mass on the right scale. The standard mass on the right scale. Okay. We also have precautions needed when reading the beam balance. The first precaution needed when reading the beam balance is the first step or the first step. Your bare hands must not be used in picking the known masses. You don't use your bare hands. You use first step to pick your known masses. So we also have known masses here, different known masses. This is a mass of 50 grams, mass of 50 grams, another mass again of 50 grams, this 100 grams. These ones are known masses that can be recorded using the beam balance. Another precaution is that objects are always wiped. You have to wipe it. Use rag and wipe this in order for you to have accurate measurement. Then the next one is all objects must be allowed to be cold before measuring it in the beam balance. So since we have the beam balance, this is called the beam balance pan. This is the pan, the scaling pan. And these ones are slotted weight. Slotted weight. These are slotted weight. Slotted weight. Pause. These are slotted weight. Slotted weight. Slotted weight. These are slotted weight. The reason why this one is called triple beam balance because we have the first graduation, which is in 10 grams. 10 grams. The second graduation, which is 500 grams. Then the third graduation, which is 100 grams. So if you add all 500 plus 100, 600 plus 10, 610 grams. That is the highest this triple beam balance can read. That is the highest this triple beam balance can read. Now, for you to read your values in your beam balance, triple beam balance, you have to adjust everything to 0. Adjust the slotted mass to slotted weight to 0. This slotted weight, you adjust everything to 0. Then after adjusting everything to 0, with your first step, you now carry your known mass. Let's say you want to record this known mass of 500 grams. You place it on the pan. As you place it on the pan, the mass of 500 mass, you place it on the pan. As you place it here, as you place it on the known mass, this will move to this point and you be adjusting your slotted weight till you have a balance where the slotted weight you have a balance at, let's say you have a balance here at zero, to balance at zero. Once the balance at zero, you now read the value. You now read the value. For example, if you have a value here, you also have a value here. So for us to read this value now, we have 300 grams plus 60 grams because this thing must align with this one is aligning with 300, this one aligned with 60, then this other one aligned with 6. So 300 plus 60 is 360 plus 6, 366 grams. So 366 grams. Let's say the weight we are trying to measure is 366 grams. But this weight is 500 grams. You place it, you have here at zero, this one at zero, then this other one at 500. That's to say this weight, this mass is 500 grams. That is how to read values on the beam balance.